Greetings, everyone, and welcome back as we resume our lessons after a brief pause. Today we are going to be looking about taking a look into Docker. We want to start our lessons with containerization. All right, what is Docker? This is our schedule for today. We're going to look at what is Docker. We're going to look at containerization versus virtualization. We're going to look at advantages of containerization. And then we're going to see how you can install Docker, which all of you have already done. That means that part has already gone. Then we are going to understand the terminologies that we use in Docker, which we have images, we have containers, we have hosts, we have clients. So that is what we are going to do for today. So to begin with, did anybody try to get anything about what Docker is and everything about Docker? Who tried to do any research about Docker? Did anybody try to do any research about Docker? Yes, Mr. Kiba.
Yes, from the little I got about Docker, Docker is a visualization tool that helps us as developers or DevOps engineers to deploy applications in a fast and a more safe and convenient method.
All right, there is a terminology you use there. Docker is a virtualization tool. Do you know the meaning of virtualization?
Actually, sir, for me, like a basic virtualization may mean something that is not existing, but we can see. Really, I don't really know much.
Okay, that is why I wanted us to really go into the terminologies very well. That is very good of you because you already had everything. If you look at the part 3 of our schedule today, you will see that we are going to be talking about containerization versus virtualization. Those are the two things that we are going to be talking about: containerization versus virtualization. Okay, to begin with, we'll have to start with a little story about the development. Okay, yes, Adija.
So I also did a little bit of research, so I try to understand that Docker helps developer to deploy the application to container.
Yeah, that is Docker helps developers to deploy their applications to containers. Okay, that is all English, right? This is all about English. So we are going to start looking about how we are going to start looking about how all these things function in real terms. Okay, we'll start looking about what is virtualization, what is containerization, what is containers, and all the like. All right. So what is Docker? Let us go to the demonstration board. What is Docker? As I said, we should begin with a story of multiple operating systems. Today we have so many different types of operating system. You have Windows operating system, we have Mac operating system, we have Ubuntu operating system, and inside so most of those systems there are multiple systems. Okay, we have been having so many systems of late. So we have Ubuntu, we have Windows, we have Linux, we have Mac, we have everything. So if you are supposed to, and within Linux, if we say within Linux, there are so many different types of operating system. Under Linux, you have Ubuntu, you have Red Hat, you have the Linux itself, and the rest. So there are so many different types of operating system. So people started thinking that, wait, if we are having all these types of operating system, then why can we not make it in such a way that one person can have one computer with all these operating systems inside, because it started showing that if you are a Windows guy, you are a Windows guy, you need to buy this other operating system in order to learn, might be Linux, right? And if you are a Linux guy, you might need to also start learning now Mac. Okay, so if you want to learn all these operating systems, you have to buy different computers. The worst thing is that under Linux we have different versions. We have Ubuntu, we have Amazon Linux, and then we have Red Hat. Then there are so many versions of Linux, so many versions. So you discover that all these systems are operating differently. So if you have to learn all these systems, you are supposed to learn buy at least 10-20 different computers with all the systems installed inside. Okay, so people started thinking about ways of making the systems available in one computer. Okay, so the very first idea that came was the idea of virtualization. What is virtualization? Virtualization is a type of a situation in which you have a computer. This is your Windows computer, for example. You have a Windows computer, and inside a computer you have something that we call a hypervisor. You have what we call a hypervisor, right? You install a hypervisor inside your computer, and then on top of this hypervisor now, you are able to install different operating systems. You install different operating systems. You can install now various different operating systems, and then on top of these operating systems now, you can install your different applications and start using them. These are applications now. Install your applications and you start using them. For example, you can have a Windows computer, and then inside the first Windows computer, inside the Windows computer, you install a hypervisor. Now, on top of the hypervisor, you can install now your Linux, and you can install now your Mac, and maybe another form of Linux. You can install your Ubuntu, right? Now, on top of this Ubuntu, you can now install your applications. For example, Jenkins, right? You can now install your Jenkins. That means you have Jenkins installed in Linux inside your Windows computer. You have Jenkins installed in Mac inside your Windows computer, and you have Jenkins installed in Ubuntu inside your Windows computer. This is how the first ideology came up. Now, what is the problem that is happening here? You discover that in this type of architecture, with this type of architecture, the hypervisor takes all the operating system of the host machine. So because this one is technically called the host machine. Okay, this is the host, and then this one is the client, right? This is the host and this is the client. So if you ever hear of client operating system, then we are talking about an operating system inside an operating system. Okay, this one, the main operating system is called the host operating system, and then the operating system that is installed inside is called the client operating system. Okay, now the client operating system, for it to be installed, it has to be installed on top of a hypervisor. That is the first thing you should know. the client operating system must be installed on top of a hypervisor. There are so many different types of hypervisors, so many different types. Okay, so you will learn about, there is one hypervisor for Windows even. All right, so the problem with this architecture is that what? The problem with this architecture is that this hypervisor gives particular resources to various hosts. Before you install this operating system, this client operating system, the hypervisor is going to ask you, what is the maximum amount of storage you want to give to the client operating system? You might then say now that you want to give it, might be if you had, let's say you had here 500 GB, right? If you had 500 GB at the level of the host, then you are going to come here and then you say that, okay, I want to give you 20 GB, and then you can say I want to give this other one, let's say, let's go for 30 GB, and then you can say I want to give this one, let's say 25 GB. Now, what is the problem with this architecture? The problem is that if this guy starts having a lot of space and needs much compute capacity, it is going to be limited with whatever you attributed it to here, right? That means it has a limited access to the compute and storage capacity of the host. You know, the compute capacity and the storage capacity, you know, the difference between them. The compute capacity here might be, this hypervisor might be having, let's say, as a level of at the level of compute, it must be having let's say i5, and we know the meaning of i5. If you take we'll take 5 computing capacities with 2 gigahertz, we will arrive at 2 times 5, which we are going to have is it 2 times 5? Yes. Okay, let's take 3. That means if we have an IP and a processor of 2 gigahertz, please, a processor of 2 gigahertz, and there are 5 of those processors, then you take 2 of the processors times 5. That means you are going to have 10 gigahertz of processing capacity here. Now you can decide to give this one, let's say 2 gigahertz of processing capacity. So you have the compute capacity, it is measured in hertz. The compute capacity is measured in hertz, and the storage capacity is measured in gigabytes. All right, this is gigahertz, gigabytes. All right, so you can decide now and say that, fine, I want to give this one 2 gigahertz and 20 GB. Now, what if the necessities, the applications that you are installing on this client operating system, what if those necessities grow bigger and bigger and bigger? What will happen? You will not be able to increase this capacity here. You won't be able to increase it anymore. Once you give it, you have given it. There is no way of increasing it. So that is a big problem with respect to hypervisors. Okay, and then the issue is that hypervisors, this layer of an operating system with hypervisors is becoming a problem because it makes them slower. That means when you give a command here, the command has to run from the operating system, from the because you do not give the command directly on the operating system, you give a command with your application, because what you use is the application. Please, this is what is interesting to you. What you are using is the application. So when you give a command on your application, the command passes through the client operating system here, and then finally enters into the host operating system. So it passes through this layer. Okay, That those are hypervisors. That is how people started thinking. Now somebody brought the idea of Docker. How does Docker behave? How is Docker behaving? For Docker now, the architecture actually changes. Okay, how is the architecture for Docker present? Now, in the place of Docker, this is what we are going to have. We have the host still there. This is our host. Now, on top of the host, we do not have any more hypervisor. Now, what we have is Docker. We do not have any hypervisor. What we have is Docker. And on top of Docker, we can now install applications directly. These are applications directly. What have you discovered that has changed? What have you discovered that has changed? Now, with Docker, there is an elimination of one layer. What is that layer? What is that layer that has been removed? The client operating system is no more there. The client operating system is no more there. And the fact that the client operating system is no more there, what has happened? A lot has changed. The fact that the client operating system is no more there, the applications are having direct contact with Docker, and Docker is taking every resource of the host operating system. Which means that if this operating system had 500 GB, all these applications that are installed on top of Docker, they have access to this 500 GB. If this operating system had a compute capacity of i5, that is 10 gigahertz, all these applications have the same access to the 10 gigahertz compute capacity. So Docker came to cut off that extra layer which hypervisors were actually imposing. And the extra layer was the client operating system. The client operating system was taken off with Docker. Okay, so that is the history behind Docker. I don't know if I was able to explain it very well. Can somebody tell me if you understood the architecture of Docker, or there is some need for additional explanation? Is it clear?
It is clear, sir.
All right. We go with Declan. If Declan says it is clear, then it is clear for everybody. Is that what I'm thinking?
It's clear. It's clear, sir.
All right. If it is clear, then we go ahead. Okay. Now, let us look at the terminologies in Docker. Let us look at the terminologies in Docker. You always hear containers, containerization, everything, blah, blah, blah. Yes. What is containers? What are images? What are all those? Okay. So generally, if somebody asks you, like I asked the question, what is Docker? The first answer you should give is Docker is a containerization tool. Docker is a tool, first of all. You remember, I always say this, when we were back in school, we always had in Form 1 definitions, and that was one of the most difficult things to ever cram, definitions. What they'll ask you, what is this? Define this. If you don't know what that thing is, that definition goes off. So what is it? So from what it is, you can now say what it does. Okay, So with our own here, Docker is a containerization tool. Just have to know that Docker is a containerization tool. So from there, you have already said everything that it does. It is a tool. What type of a tool? A containerization tool. Okay. So what is Jenkins? Jenkins is a CI/CD tool. It is a continuous integration and continuous development tool. What is Git? Git is a version control tool. Git is a version control tool. What is Maven? So you should know all those tools and know exactly what they do. Now, this will help you in building your CV, because when you are going to be building your CV, there's something they call a technical document, fish technique, where they will ask you, with respect to containerization, which are the tools that you master? You say you master Docker. With respect to version control, which is a tool that you master? You master Git. With respect to CI/CD, which is a tool that you master? You say Jenkins. Right? So you should know exactly what each tool does. So Docker is a containerization tool. Okay? And I've taken time to explain to you the difference between containerization and virtualization. Virtualization was what first of all came before containerization came. So for an application to be installed into Docker, this is what we are saying. For an application to be installed into Docker, that application must be containerized. That application must be containerized. I know you might be wondering within you that, okay, if they say for an application to be installed in Docker, that application must be containerized. What is the meaning of containerized? Because if I have an application, for example, I have my, let's take an application that we use every day. You have your VLC. VLC is an application that you use. You have your VLC, and they tell you that for VLC to run in Docker, you need to containerize it. So why containerized? That is the question. Why must I containerize an application? What is the problem with the first nature of applications that we are running? Why can I not containerize the application? I would like to answer that question by bringing you to my application database. You see, I have a lot of applications that are here, so many applications that are here. I'll take an application, for example, an application that most of us, we are always running behind when we were still computer novice, which is Encarta. This Encarta like this, I always install Encarta for people when I was back in school. Why was I installing Encarta for people? Because people never knew that in order to install Encarta, you needed to install NetFrame. Encarta needed NetFrame in order to work, and Encarta needed advanced video players. They'll tell you that when you install Encarta directly, just like that, they'll tell you that it needs Adobe in order to play videos, or for you to get sound, you need this in order to install so that it gets sound. So the application needed several different patches to be installed for the application to function in Windows. They'll tell you that your Windows machine must have this in order for Encarta to play. You need to update your Windows machine from this to this in order for Encarta to be installed in your computer, right? So you will have to look for all those various things that they need Encarta to be installed. All those things that they need Encarta to install before Encarta runs are what we generally call in software development dependencies, right? Dependencies. Anything that needs this application to run is what we call a dependency. So take all the dependencies that you need for this application to run and put them inside the application. That is the meaning of containerization. Okay? So in other words, containerization is packing all the dependencies of an application and compiling them with the application itself. Filling them, that is zipping them inside the application. So if you pack all those dependencies and zip them inside that application, then the application now is containerized. That application now is containerized. So with an application containerized, it needs a particular system for that application to function, and that system that it needs is what? It needs Docker in order to function. It needs Docker. So containerization is packing all the dependencies of an application and putting them together. That is containerization. Okay, I hope we understand the concept of containerization very well. That is the concept of containerization. Now we are going to have technical terms that we are going to use. The first technical terms is we are going to talk about images, containers. We have already talked about host and client, Docker host and Docker client. You already know what a Docker host is and a Docker client is. So this the physical computer where Docker is installed is called the Docker host. So that your computer that you are having there is your Docker host, right? Your computer is your Docker host. Okay, so that is the Docker host installed there. So where Docker is installed is the host of that computer. So what is a Docker client now? What is a Docker client? Who can think of a Docker client? Who can think of what a Docker client will be?
So I think
Yes, I mean I'm listening to you, Declan. You just muted.
yes, I think it is a a containerized application that is installed in Docker with all its dependencies.
A containerized application installed in Docker with all its dependencies. That's the container, right? That's the container itself. Although when we come to container, you will see that it's a different thing. But who can tell me what a Docker client is? Yes, Mr. Kiba, you raise your hand up.
Yes, I almost wanted to say the same thing that Declan already said.
All right. For those of you that successfully installed Docker, there is a statement that I was always saying. I said, go and install the Docker client now. After you finish installing Docker, I said, go and install the Docker client now. The Docker client is the terminal through which you are going to be running your Docker commands. So for most of you, I ask you guys to install Ubuntu. So in my own case, my Docker client now is Ubuntu, right? This is my Docker client. It is from this Docker client that I am going to be running my Docker commands. Okay, so that is your Docker client. So the Docker client, you can have any terminal. You can decide to have any terminal. You can have people use PowerShell terminals, others use any other terminal you can decide to use, right? But my own Docker client is that I love so much is Ubuntu. So that is a Docker client. Okay, so let's come back to terminologies now. Let's go back to terminologies. The first terminology I would like us to look at is, we have already looked at a hypervisor. You know about a hypervisor, right? So I will say a hypervisor is a tool installed in an operating system. We'll talk about a hypervisor It is a tool installed in an operating system that helps you to install a client operating system. That is a hypervisor. Which on top of that client operating system, you are now going to install your application. So that is a hypervisor. Okay, a tool installed in an operating system that on top of that operating system, you are going to install your applications. That's a hypervisor. Now, let us look at what is a container. What is a container? Before coming to container, instead, I would like us to take image. What is an image? Yes, Mr. Kiba.
No, sorry, sir. I thought you were asking the question, what is a container? I wanted to say containers are running images.
Good. If we have, after we must have installed Docker, we will need to run images. So when you containerize an application, listen to my statement and my English very well, please. When you containerize an application, what you get is an image. Is that clear? When you containerize an application, what you obtain is a Docker image. I repeat again. When you containerize an application, what you get is a Docker image. What is containerization? Packing all the dependencies of an application and putting them into one single container. It is some sort of an irony here. How can you pack everything and put into a single container? But we say when you containerize an application, what you have is an image. True. What you have is an image because that image cannot function in its state of an image. You just have an image of what you have containerized. So if you want a container now, you have to run the image. So what is a container? A container is an executed image, right? A container now will be an executed image. So once you take a container and you run it, it becomes an executed image. And when that image is executed, it is now known as a container. Okay, when the image is executed, it is now known as a container. So there are these things that you should know very well and do not make mistakes with. A Docker image, a Docker container. In Docker Hub, there is a place called Docker Hub, right? All of you need to create an account in Docker Hub. All of you need to create an account in Docker Hub. In Docker Hub, what are you going to see? You are going to see, this is the official website for Docker. Okay, you are going to see all kinds of Docker images. All kinds of Docker images. This is where you get all kinds of Docker. If a Docker image exists, this is where you will see it in Docker Hub. So you are going to create an account in Docker Hub where you are going to have access to all verified Docker images. Okay, so accounts created in Docker Hub are either private or public. Docker Hub is a public repository. Docker Hub is a public repository. You can create your own repository where you keep your own Docker containers or your own Docker images, please, not containers, your own Docker images. You can create your own repository where all those images are kept. Okay, so the first thing that you do in order to install, we have already installed Docker. All of us have already installed Docker, or if we have not, then we certainly know the process of installing Docker into our computers. We have already done so. So the first thing we are going to do is, after having installed Docker, what is the first thing you need to do? The first thing you need to do is run Docker commands. Run Docker commands. How do we run Docker commands? There are a series of Docker commands, so many of them, that I am going to give you just a list of various Docker commands. Okay, the first command that we are going to look at is docker pull. Docker pull. What does docker pull do? Docker pull, this is your operating system. This is your Docker machine here. This is your Docker machine here. This is Docker hub here. When you run docker pull will pull the image from Docker hub and keep it inside your computer. You get it? When you run docker pull pulls the image from Docker hub and keeps it inside your computer. That is the meaning of docker pull. Okay, after you run docker pull, let me give you the after you run docker pull, then their image name. We run docker pull and then you write the image name. Docker pull image name, right? This is how you write. Example, if I want to pull an image of, let's say I want to pull an image of Tomcat. I want to pull an image of Tomcat. The first thing I need to do is I need to go to Docker hub. I need to go to Docker hub. Docker hub. You should have an account here, and then you sign into your account. So now if I just say Tomcat, okay, this is the official image for Tomcat, right? What is the command to pull? What is the name? My main thing is to look for this name like this, because we all know that the command is docker pull. Docker pull what? Docker pull Tomcat. Okay, so if I take docker pull Tomcat, I'm going to pull the image Tomcat. Okay, so I take it here, I copy the command. Now I go to my Docker client. I am in my Docker client. The first thing I'm going to do is, the first thing I have to first of all enable Docker. I must enable Docker. If I don't enable Docker, I will not be able to do Docker commands. I have to first of all make sure that Docker is enabled. And when you open Docker, you come down here, you see when Docker will be booting out, you see here that Docker is starting. It is an application that is as you must have seen, it is 600 and something megabytes, so definitely it is a heavy application, very, very heavy. So when you pull it, you give it some time for it to actually run. So I need to make sure that my Docker is okay and running when it is running before I'm able to run my Docker commands. Okay, let's try to run the command when Docker has not yet started. This is docker pull tomcat, right? I run the command. You see the command is stuck in a loop. It's stuck in a loop. It does not recognize. Command is stuck in a loop. At the end of the day, it says that what? Request returned internal server error for API. Yes, Mr. Kiba. I saw your hand up.
Yes, I was asking while we are waiting for the Docker engine to start. This Docker account, is it free of charge to create?
Yes, Docker account is free. The Docker account is free to create, please. Docker image, they are public Docker images. They are public Docker images that you can use at your will. Those images are free, but for private images, you cannot even see them in Docker Hub. Private images, you will not be able to see them in Docker Hub because companies have their images which are stored in their own private repositories. So when we talk about private images, please, you will not be able to see them in Docker Hub. Okay. So let's give some time. So when you are creating, don't be. I know we are all afraid of money. When we are creating, don't be afraid of the fact that you are going to be built. You will not be built. Okay, our Docker engine is up and running. Okay, so now we can run our command again. Docker pull. Let's clean the. Okay, Docker pull tomcat. That is the image. First of all, let's check whether there is any image in our repository. We'll run docker image ls. Is there any image? There are images. Okay, these are images that I actually pulled some time ago. So I want to delete all these images, all of them. So the first thing I do is docker rm, that's I'm removing docker rm -f, docker rm -f. I'm just removing all the images. Docker ps -aq. Docker remove requires at least one. Okay, docker m, we have our images running. Yeah, okay. Docker rm -f ps -aq. What am I missing there? Okay, let's remove one after the other. Okay, let me remove at the container name. Docker container name was what? My app. Do I need to stop it? Is it running? My app. I do docker rm my app, and then take the container id. I want to use the container id instead of the container name. error, no such container is found. Okay, that is at the level of the container. Okay, that means there is no container found. So let me clear now the images. So I think there is no container found in my system. So now I have to remove the images. See all the image names: docker image ls. Okay, these are the various images that are found in Docker. So removing all the images, I do Docker delete. It's not a. Give me 1 minute, please. Let me verify my command. Give me 1 minute. Let me verify my command. Okay. I will send you this this command list for all the various commands. Anyway, for us not to waste time, just take a look at all the various images that are here. We have these are the various images that are here. So we expect that when we run docker pull hyphen Tomcat, we'll see an additional image of Tomcat. So let's validate. So I am pulling the Tomcat from Docker Hub. Okay, I'm pulling the image from Docker Hub. Let's see where we are. I said when you run docker pull, the image leaves from Docker Hub into your computer. All right, so we have pulled the image. Here is the image now pulled. Okay, good. Now if I run docker image ls, you see that this is my image that I pulled, Tomcat. All right, this is the image that I pulled. So in order to execute this image, I need to do docker run Tomcat. I just do docker run Tomcat. I'm going to execute my image with docker run. So let's give it some time for it to install Tomcat. For first time installation, it usually takes some time. Okay, now Docker has Tomcat has installed, but you see something that happened. Tomcat installed and the screen is still open here. Okay, we saw all this installation as Tomcat installed. The screen did not disappear. Tomcat installed successfully. So if I want to know that Tomcat installed successfully, let me open another window of my Docker client. I open another window. I run docker container. Remember, I ran docker container ls at docker image ls at that time. Now I'm running docker container ls. Now you see that there is a Tomcat installed in my computer. Okay, there is a Tomcat now that is installed in my computer. So if I run docker image ls, I will see all the various images that are found inside this computer. And if I run docker container ls, I will see all the containers that are running inside this container. Okay, so we have learned three commands so far that I know that you should know. First command is docker pull. We get docker pull image name, then that image will leave from Docker Hub into your computer. That's the first command. Second command, docker run image name. These are the commands that we have learned, please. We have learned docker pull tomcat image name, right? Tomcat. We have learned docker run tomcat, that's the image name. Now we have learned docker image ls, that is to see all the images that are found in your machine. We have learned docker container ls, that is to see all the running containers in your machine. These are the 4 different docker commands that we have learned today. Okay, so at least today you can go home, you pull images from Docker, and then you install the images in Docker, and then we are going to learn 2 other commands, and then you stop the images from running, and then you stop the containers from running. Let me use the terminology very well. You stop the containers from running. When you stop a container from running, what happens to that container? When you stop a container from running, the container is at a stop stage, but the container is there, right? For example, when I run docker container ls, I will see that these containers are running. This is my docker container ls. I'll see that these containers are running, right? But when I run docker stop container, if I run docker stop, then I give the container id, which is this one. So here, when you run docker container ls, they'll give you container id, which is this image, where the image is coming from, which is Tomcat, the command to run it, and everything. They'll give you the image was created 5 minutes ago. They give you everything. Okay, this is the port where the image is created, okay, at port 8080. Okay, so how can I access port 8080? Is it possible that I can access port 8080? Tomcat is existing at port 8080. Shall we try? Let us try. Why are we doing something? Let us try. They say we should run local host hyphen 8080. That's it. Also local host hyphen 8080 to make sure that our container is running. Okay, have you seen that our container is running? This is our container running without any problem. Oracle database 10 Express edition. No, there is a problem. I have okay, we'll come to that. What is just happening is that I have Oracle installed in my computer, and Oracle is also running at port 8080. Okay, so in order to change the port which Tomcat runs, we will come to that. We will come to port binding, how to change port and all the like. We'll come to that in our previous in our next edition. So but when you run Tomcat in your machine, you look at all these, you come and see here that the Tomcat is running at port 8080. Since it is in your machine, when it was in the cloud, what did we used to do? We used to run the public IP and then we add 8080. But now we are in our machine, so we, instead of running the public IP, we write local host, and then we give the port. Okay, when we write localhost, then we give the port. We are going to arrive our web server. Tomcat is a web server. Okay, Tomcat is a web server. So when we run our localhost and put 8080, we are going to arrive at our web server. I cannot arrive at my web server because I have my database, Oracle database, that I've installed and exposed it in port 8082. So I'm going to teach you how to, while installing a container, you can map the port and change it. Okay, that's a whole lot of topic, how to map port and change it to different ports. So, but as I've said, Tomcat is already running. The idea behind here was to teach you how to stop a running container. So I'm going to run docker stop, and then I give the container ID. I want to stop this container. Docker stop container ID, right? So it is telling me that this container has stopped. So if I run docker container ls, do I still see the container? I don't see the container anymore. But is it that the container has been deleted? No, the container has not been deleted, right? If I want to see all the containers that are running, both stopped and it's not that Adija is joining in. If I want to see all the containers that are running, both stopped and running, I will run docker ps -a. Here I will see all the containers that are both running and stopped. So you see that our container is here, right? Our container is here, but it is not in the running state. When you see the status of that container, it is what? Exited. The status of the container is exited. So because what did I do? I ran docker ps-a. Docker ps-a is doing what? It is going to list you containers that are both running and stopped. Okay, so we just stopped this container, and if we want to start the container, we can run docker start container id, and then we start back the container. The container has started. So if I run container docker container ls, now I can see the container. Here is the container running. Docker container ls, I will see the container running. So what have we added to the commands that we have learned today? We have added that we now know the meaning of docker stop, which is to stop the container that is running. And then we know docker start, which is to start the container, of course, and its name. Always put its name to start the container. Then we have learned docker ps-a, which is to list all the various containers that are both stopped and running. Okay, these are the commands that we have run today. And then we are going to run another container. This container now is to delete. This command is to delete running containers. Okay, we want to remove containers that are both running and stopped. We want to remove them. Okay, in order to remove a container that is both running and stopped, this is the command that we are going to use. We are going to use docker rm -f $docker ps -acure. This command is going to remove all the containers that are both running and stopped. Okay, so we see the container, the command ran successfully. Now let us run now docker container ls. We discover that there is no more container there. Let us run docker ps hyphen acure. This one is to list us the containers that are both running and stop. We still discover that there is no container again that is running and stop. That means what? We have deleted the containers that are both running and stop. There is no more container. But do we still have images? Docker image ls. We still have images. So you see that images are totally different from containers. So we can still run an image from a container from an image and delete the container and still run it again from an image insofar as the image is found in our machine. We can rerun it from our machine several times. Can we delete the image from our machines? Can we delete a Docker image from our machines? Yes, we can delete a Docker image from our machines. How can we do before we can delete a Docker image from our machines, right? What is the command to delete Docker images from our machines? So in order to delete a Docker image from your machine, you run the command docker rmi. RMI stands for remove image, right? Docker rmi image. So if we want to delete image one by one, let's just start from Tomcat. Docker rmi remove image. Let's start from Tomcat. You see that rmi, good. Now let us run docker image ls. Can we still see Tomcat there? We can no more see Tomcat there. Tomcat is already removed. Okay, Tomcat has been removed. Now somebody will always like the easier way. Please sir, can we delete all the images that are in our repository at once? Yes, but you should be very careful when you are running a command to delete all the images that are in your computer. Docker rmi, I think, no, docker rmi hyphen f docker ps hyphen acure. It needs at least one argument. Let me get the command very well. Okay, docker system prune hyphen a. No, this command will delete all images that are this command will delete all the various images that do not link to any container. So docker prune hyphen that unknown shorthand docker system prune hyphen, is there a problem with my spelling? Docker system prune okay. Now okay, when you encounter an event of this nature, you always have they would always tell you run docker rmi -help. Now here is what you are going to have. They will tell you that usage, the RMI will give you an option and then the image. Okay, what do you want to do with the option? You want to delete, right? And then what do you want, what option do you want to do with it? You have to delete this particular image. You give the image name, right? For example, docker image rm remove, docker image remove, docker rmf remove. That they give us various different options. Okay, then when you use -f, it means you are forcing the removal. That is what they are explaining to us here. Okay, so what are we going to do? We are going to run docker rmi. So where are we standing now? Okay, these are the various commands that we have learned today. We have learned how to pull, how to run, how to list the images, how to list the containers, how to stop, how to start, how to list all the various containers that are both running and stopped. Now we have also learned how to delete an image, which is docker rmi image name, right? Docker rmi image name. That image will be deleted. Cool. So here we are. So far so good. Is there any problem or any difficulty somebody is seeing? I heard somebody's microphone was already unmuted. I've been talking alone for such long a time. Yes.
Yeah, hello, sir. I want to find out when we pull this image from the Docker Hub, where can we get this in our local host?
When we pull the images from the Docker host, from the Docker Hub, where do you find them? Inside your machine, inside your local host. Do you want to see the images inside your machine, or because when you run docker image ls, all the images are listed to you, except that you are telling me that you want to go to that particular repository where those images are found. Is that?
Yeah, like for example, if I'm not having, like, without the internet, can I see these images like a file or something in the, like in my local computer, like the desktop?
Yeah, but when you run docker image ls, you are in your desktop, you are in your normal machine. You see the images that you have pulled without an internet in your machine.
Okay.
With docker images, you see the image in your machine. But if you want to see where the images are located inside your computer, that means inside the physical images, where they are located inside your computer, you are going to have to go to the docker registry. Okay, you have to go to the docker registry, and the docker registry, you have to change your you have to run cd etc run ls here. Now you have to search for your docker. Okay, do you see any docker here? When you run your ect, you have to search for your docker repository. Now whether it is ect, or if it is not ect, then it should be var. However, it is either ECT or var, and it should be under libraries. Now in libraries you should have you seen Docker desktop? You should change it to Docker hyphen desktop. Your images should be found somewhere inside your Docker engine. However, we'll come to that.
Okay, sir.
We'll come to the repository where all your images are found. All right. So for today, I believe that we can at least pull images from Docker Hub, install them, verify that they are working, and delete them. Can we do that?
So first I all need to finish in my Ubuntu, then I can get to that. But for the explanation, it is good. It's okay.
Which means your problem is the Ubuntu, right?
I just need to install it. But for the class, I think it is okay.
All right. Roberto, are you still there? You left at one moment. I'm not sure Roberto is still there. Adija, is it okay? You two left. Yes, Mr. Kiba.
Yes, you talk about Tomcat as we can view Tomcat on the port 8080. So how can I do to get the port for other images? Or should we practice only on Tomcat today?
No, when you install any image, right, you do Docker container ls. Okay, let us just look at something here. When you install any image, just do Docker most of the images come with port 8080 originally. Okay, most of the images comes with their port 8080. While installing the image, you can change the port. We are going to come to that. That is one topic of our next class. While installing images, you can change their ports. Okay, for example, we can take Nginx. If you take Nginx, you discover that this is the official Nginx, Docker pull Nginx. But this Nginx will still come with the port 8080 if I install it. Now, if I want to install Nginx without it installing in the background, I'll put -d, right? I'll put -d, -p. -p now I am passing the port. I can pass my port now, which is my new port. Okay, I can pass my port, which is maybe 9090, right? And the port is passing to 8080 because Nginx is port is 8080. All right, if I run I'm sure there's a problem with my ports here. -p 9090, still it refuses my port. Anyway, let me run without the ports. -d. Okay, all right, it is pulling the image. So you see, the first thing is images are must be in your local machine. They must be in your local machine. When those images are pulled, now I run Docker image ls. You see now that this is Nginx. Okay, so if I run now Docker run Nginx, what is Nginx? Nginx is also a web browser, a web server, please. If I put Docker run Nginx, Nginx will run. Okay. Oh, this is where I was supposed to put the background, the detached mode. Now Nginx will run. When Nginx runs, I don't want to Nginx will run, but when it will run and finish, the terminal remains open. You see, the terminal is open, so I don't want to stop it from running. Now I come back to a terminal that is already open. Now I run docker container, because it is already running, ls. Now when I run container ls, okay, Nginx is now at port 80. Okay, you see the port here. Okay, so I can come now here and say localhost 80. Unfortunately, still I have my Nginx running on localhost 80, which is a container that I installed in my when I was practicing far back ago in my PHP. Okay, so most of these things, when you do it, you will see your web browser comes without any problem. My Nginx is installed and is running on localhost 80. This is Nginx running on localhost 80, but my own is already having a web server that I've installed in it. Okay, a website that I've already installed in it. So you install your own, it will come, but it will not have anything. You go and try it and you will see it. Is that clear?
Okay, so yeah, it's clear. Yeah.
Yes, I was talking to Adija. Adija, I have not heard about you. Are you even still on?
Yes, sir, I am.
Are the concepts clear?
I have not clear it, so it's not now for me to download the Docker and the Ubuntu.
Docker is very heavy.
I started before the class started, so after the class I'm going to finish. So.
All right. Okay. So please, everybody should come to class tomorrow with at least a web server installed and functioning. That is your assignment. Everybody should come to class tomorrow. You share your machine, you share your screen, and show your web server functioning. That is, you are going to run ls in your computer, and we will see the container that is running in your container in your computer, and then you are going to show us the container demonstrate in your browser by running your local host. You can take Nginx, you can take Tomcat, you can take PHP. There are so many web servers, so many of them. You can take any web server, install it as a container, and then you make it work in your machine. That will be our assignments. Is that clear? And I'll have to check it first. Everybody is supposed to do that before we continue. Is that clear? Is it clear to everybody?
It's clear, sir.
All right. Thank you, everybody, and see you guys.
It's clear, sir.
And when you finish, always delete your containers. Always delete your images, please. Always delete your images and delete your containers when you finish. All right.
Yes, sir.
All right. See you guys tomorrow. Your notes will be updated, and I think I'll make sure that the lesson goes also operational before night. All right. See you guys tomorrow. Bye bye.